The production of this program is made possible thanks to the support of the following and viewers like you. There are 6 elements that play a key role in optimizing fuel and chemical production, says Mohammad Doostmohammadi of PH7. Without them, green hydrogen, low-carbon steel, biofuels, and other climate technologies are not possible. Those 6 elements are platinum, palladium, rhodium, ruthenium, iridium, and osmium, and they are among the rarest elements on Earth. It's challenging to identify ore bodies with mineable resources. However, there is an emerging opportunity in recovery. There are 17.4 million troy ounces of these elements that have already been mined and are available to be recovered from catalytic converters, mobile phones, computer disks, and aircraft turbines, to name but a few. Until now, however, the process of recovering these elements was uneconomical. Doostmohammadi says, these challenges notwithstanding, several factors have combined to spotlight their growing importance and the need to recover them. I invited Mohammad Doostmohammadi to join me for a conversation that matters about the process his team has developed that reduces costs and increases productivity in the realm of critical mineral recovery. Mohammad, welcome.
Thank you. Thanks for having me.
We really are talking about the essential elements of the green economy. Without these 6 elements that you've identified, can we even hope to realize our vision of a lower carbon environment?
That's a very good question, and I believe it is impossible. So without having critical metals, which are vital for energy transition, there is no energy transition. And the reason is that you see lithium-ion batteries, you see electrifications, turbines, you see hydrogen technology. All of them are relied on one of these critical elements and metals. So for electrification, you need wires, you need cables, and they need copper. So without copper, it's impossible. The same for lithium-ion batteries. For batteries, you need cobalt, nickel, lithium, all of these elements that without them, it's impossible to get to our net zero. And the same for hydrogen technology. You need platinum, you need iridium, you need palladium, you need all of these critical metals that helps us to get to our net zero goal by 2050.
So what role, I know you talk about copper, you talk about lithium, and I think most of us go, yes, we recognize that. But it's my understanding that if you want to have batteries that can recharge at a rate that makes it practical to have transportation where you're recharging, platinum and palladium may already, it's being identified as those materials that can help to ensure that you get the charge that you want within a timely manner.
Yeah, so there are lots of researches actually going and R&Ds that using these platinum group metals as a catalyst in lithium-ion battery as well. So there are some promising results that they actually accelerate the charging and use of 100%, just give you more mileage by using platinum and palladium. So that's a future role for platinum palladium in lithium-ion battery. Nowadays they are playing an important role in catalytic converters, so break down all the toxic emissions from exhaust of the cars, your automobile, or any other reactions, and make it to environmentally friendly gases. So for example, you produce nitrous through your exhaust in your car and automobile, they break it down to nitrogen. And it's a safe gas coming out. And they are playing a vital role as well in hydrogen. So without platinum and iridium, specifically these 2 elements, there is no hydrogen. So they are playing a critical role in every single supply chain of the hydrogen, from producing hydrogen, breaking down natural gas to hydrogen, electrolyzers, color-alkali electrolyzers, all the way to fuel cell. It's relying on platinum and iridium as a catalyst for any of these chemical reactions.
Right now, we mine those resources. But to develop a mine, you need to have established an ore body that makes economic sense in a jurisdiction that will let you do that. How difficult is it becoming to be able to develop new mine sites to meet the growing demand globally for all of these elements?
So it's getting harder and harder every day. I believe to answer this question, we can look at Canada as an example and see how long it takes to have a permit for a mine. An average timing is 10 years.
Oh, I think it's more than that.
It's true. It's
closer to
getting more and
15.
more, and exactly. And we don't have enough of these resources in the earth as well. So for how long we can mine? We already mined all the easy stuff, all the high-grade stuff. So what we encounter right now is low-grade, hard to extract, and it's getting harder and harder every day to find these elements in the earth. So that's why I believe we need to rely on other resources, such as end-of-life materials, how we can extract it from those type of materials. And recycling, I believe, is going to be the key to get us to our net zero goals.
The production of this program is made possible thanks to the support of the following and viewers like you. So there's a few challenges that pop to mind when you talk about end-of-life recyclables. Number one is, how do you pull together enough of the same resources to make it worth your while to even start to dismantle the elements or the vehicles in which they're contained? By vehicle, I mean like a catalytic converter or a wind turbine blade. How do you bring those resources together in a manner that makes economic sense?
No, that's, I believe, to answer that question, we need to look back at what is the supply chain and how it looks like. So the good thing is that there is lots of value over there. So these metals have a high price, close to gold price. So they're on average, it's about $2,000 per ounce. And this is, I believe, it's a huge incentive. And there are some established recyclers all around North America, Europe, South Asia, that they are doing it already. They have started doing it, they are collecting it, they are producing the concentrate that they are shipping it to processors. And by emerging new technologies that they can recover more, they can have more, they are get more incentivized to do more of this recycling as well. So the supply chain is very important. We need to have established recycling supply chain around the world to enable us to process those materials. And it's happening for PGMs right now. It has happened for the last almost 20 years, and it's getting better and better every day because the value is there and people understand the value and the processes are there, and there are some new technologies coming in as well to increase the recovery of these metals from end-of-life materials. And I believe we need the same thing for other materials as well. And hopefully the value is going higher, and it's going to be more incentive for people to do the dismantling, recycling, collecting it, aggregating it, and then sending it to processors like PH7.
So where do you step in this chain then as PH7? What gap are you filling? We
are a processor. So at the end, when recyclers, aggregators, they collect it, they're recycling it, at the end, it needs to be processed to be able to extract the pure metals and having it back into the circular economy. At PH7, that's what we do. So we receive the materials from recyclers, from OEMs, from aggregators that they collecting it, and we run it through our process. We process them, we extract these metals, these PGMs, and produce a metal that can go back to OEMs and build more of these materials. So we position PH7 as a processor and as an alternative to current and traditional processors. So
the current is pretty caustic, as I understand.
Yes.
Time-consuming, expensive. So what are you doing that differentiates, without giving away your trade secrets, but people are going to go, okay, tell me more.
So the traditional way of extracting these metals is through smelting or acid-based chemistry. So these are the two options that you have. And it has been like this. I believe smelting is for thousands of years, hasn't changed, melting down everything to extract the metal. Easy to do, but lots of energy, lots of waste materials that you produce through this process. And another one is acid-based. So you just use lots of corrosive acid to extract these metals, and at the end you produce lots of wastewater and lots of off-gas.
Toxic wastewater.
Toxic wastewater, correct. At PH7, what's the value, the main value proposition that we have? We designed this closed loop process, which means that we extract these metals into a closed loop process that doesn't generate any wastewater, any effluent, any off-gassing, and we just reuse the chemistry over and over and over. By closed loop, I literally means closed loop, because you have your metals going in, your materials going in. We extract these metals coming out at the end of the process, and then the chemistry being go over and over, reused and reused and reused, without generating any waste.
So let's go back to the source material that you get. Are you going to get, let's say, a circuit board or a motherboard from a computer? And that would be it stripped down to that point where you go, okay, now I know that I've got the elements within that motherboard that I can use. What do you do with it then?
So when we receive those materials, they need some kind of material preparation. They will go through grinding, crushing, and we pulverizing. We produce kind of powder. And those powders go inside our chemistry. So we mix our chemistry, or lixiviant that we call it. So it's a solution that contains mostly water. So it's a water-based chemistry and some organic chemicals and some solvents. And mixture of these creates our lixiviant that is going to be mixed with the solids that is already ground and in a powder form. And it goes inside the reactor. The reaction getting started by oxidizing our lixiviants, and we dissolve selectively the metals that we need. So we dissolve platinum, palladium, iridium into the solution.
Out of the powder that
Out of
you
the
have.
powder that we have,
But
exactly.
you're able to extract individually
Correct.
in this process.
Correct. So selectively extract whatever we need,
Yeah.
and everything else just stay intact. So we do not dissolve those fibers. We don't dissolve any of the substrates or matrix that we receive. They stay intact, and our main focus is only dissolving the metals. And that's the major actually difference between us and the smelters. Smelters melt everything down to get to that metal, which is only 0.1% of the overall mass. What we do is, instead of just attacking 99.9% to extract that 0.1%, we only extract that 0.1%, attack that 0.1%. The rest stay intact. That's why we are way more energy efficient, and we just consume the energy that is required to dissolve that 0.1%.
The production of this program is made possible thanks to the support of the following and viewers like you. I can't help but think, okay, you've got already all this ground down material. Is there an afterlife for that as well in, let's say, sandblasting?
Exactly. No, that's a very good question, actually. So after that, we dissolve that 0.1% of target metals. Yeah. The rest is 99.9% is coming out. We do some just off-the-shelf filtration process, which is the solid liquid separation. Liquid that has we call it pregnant leach solution, that has all of these PGM, platinum, palladium already dissolved, will be separated from these powders that doesn't have any PGM. We have different applications depending on the source. So they can be used as a concrete filler, for example, just one of the applications. They can be used as, there are some other R&Ds that going on with different manufacturer. They can be used as a ceramic source as well. And we are developing different applications for them. So we are not extracting the metals, we recycle all of those materials as well.
So in essence, you're putting all of this back into a circular economy.
Absolutely right, and that's a goal.
So what's the scale of equipment and size of plant that you need to have to make this economical?
So let me actually go back and how we scaled it up, just to give you a story of what happened during the last 3 years. So when I started the company in 2020, and we got our first lab in 2021, in March 2021, we had a beaker with an agitator, so about 500 milliliter and about 100 gram of the solids. So that was the scale that we had. And in 2022, we scaled it up to 100 kilo per day pilot operation. In 2023, we increased the pilot capacity to 500 kilo per day of the raw materials that we could process.
500 kilos.
Yeah. And now we are at 5 tons, 5,000 kilo per day operation in South Burnaby. And that's our demonstration plant, which has a footprint of about 27,000 square feet.
Okay.
That including offices, including shipping, receiving. The plant itself is less than 10,000 square feet. So it's really compacted plant that we designed, fully automated, and we can process 5,000 kilo per day of the raw materials, end-of-life materials coming to our plants. And the goal is to build more of these plants all around the world.
So how do you then go about securing your supply line? Because as much as we like to think that people love to recycle and that things move back into that circular economy, finding that source material for you still has to be a bit of a challenge.
It is. It is a challenge. It's always, without supply, even we have the best process in the world, it doesn't work because you don't have the supply. So from the day one, we started talking to OEMs, recyclers, and we established a very good connection in the industry of platinum group metals recycling and processing. And now we are receiving the materials from largest recyclers in North America and Europe, as well as OEMs.
They're sending
they
it
are
to
building
you.
it. They are sending it to us, and we are processing it for them.
Okay, tell me that it's so brilliant that they pay you to take the material, do they?
No, so they don't pay us to process it. So what's happening is actually they pay us to extract the metals for them, and then we charge them.
Ah,
So we
okay.
extract the metals, we give them back the metals, and then we charge them some
you're a
processing
service
fee.
then?
We are a service.
Ah,
Correct.
okay.
Correct.
Right.
That's true.
And so that means that you can open up your process to a wide variety of suppliers from around the world.
That's true. Absolutely right. And now we are actually expanding our business to around the world, actually. So we build more of these plants. The goal is to build these plants locally so that they don't want to ship it overseas.
Right.
So it's going to be one plant in Europe, another one in South Asia, another one in MENA, Middle East, another one in the US. So that's how we see it. And then we receive the materials locally from local recyclers and OEMs.
So how many plants do you have in the process of development at this point?
So right now, it's negotiations are actually going pretty well. And we just started from July 1st. We started our operation in Canada. So in Vancouver, we have first plant up and running. And
like just 10 days ago.
just 10 days ago, exactly. We are hoping to have 2 more plants up and running by next 2 years.
Wow.
Yeah.
So you identified this need and developed a process to meet this need and have gone from 1 beaker
Yeah,
to 5 tons a day right now and growing.
that's true. Correct. And the need is actually, I believe it's the right timing as well, because you see how everyone is pushing electrification, renewable energy, and everyone understands the vital role of critical metals. And we appreciate that, and we want to use this momentum to grow exponentially during the next 3 or 4 years. Play our role in this electrification.
The production of this program is made possible thanks to the support of the following and viewers like you. Wow, this is a fascinating BC story.
Yeah.
I'm almost confused in some ways as to say, okay, well, where do we go from here? I get the sense that you're focused primarily on electronics at this point.
We are in main focus right now is actually on catalytic converters, spent catalysts, petrochemical catalysts, different type of spent catalysts that we receive. The next plant is going to be focused on electronic waste and end-of-life printed circuit boards.
The supply will be endless.
Exactly.
And the market for these recycled metals, equally hungry.
The market is pretty good, actually. There are so for all of these metals, actually, there's a market deficit right now. The demand is higher than supply for the metals. And the recycling is not being done properly. As you mentioned, people doesn't want to recycle. So just to give you an example, there are some materials that go to landfill because there is the traditional processes cannot process them.
Right.
Either they are high melting point temperature that they cannot go into the furnace, or they are high carbon content, or they have some chloride-based chemistry. So there are some different reasons that you cannot just melt it down. It's going to damage your furnace. It's going to damage the whole line on the refining side. And with our process, we can process those materials easily. Just give you an example, just high carbon content catalysts, such as diesel, catalytic converters, all the diesel trucks. We can easily process them, extract platinum, palladium out of them, and then having them just back to the circular economy. And right now it's almost impossible to run it separately into a furnace. So they have to blend it with other materials. It's lots of work. The return of the metals for those type of materials is about 6 to 8 months. We can extract them in 2 weeks.
2 weeks?
2 weeks. That's a huge difference in timeline. And that's one of the reasons we're getting momentum in the market. We receive the supply because there is a need. There is a need for this type of process. The next step is going to be electronic waste. Only 17% of electronic waste is being recycled efficiently. And we hope that we can play our role to increase that recycling rate and extract more of these critical metals from end-of-life printed circuit boards as well.
So what's your biggest challenge right at the moment, and how are you solving it?
To be honest with you, I believe the whole thing about growth and scale is a challenge, so it's not easy. Just people is one of them. Hiring talents, finding talents to join our team, it has been a challenge forever. From the day one till now and the future. I believe that's going to be the main challenge, because what we do is for people, and we need people to do it for people. And finding people with the right vision, with the aligned vision, understanding the culture of the company, what we have as a goal in our mind, it has been a challenge, and that's something that we need to overcome every day. Scale up is, I believe, it's getting better because we already scaled up from 3 different phases, and it helped us a lot to understand the challenges that we saw. But again, next plant is going to be different from this plant. So still we are learning. Still we consider it as R&D, and that's why we call it demonstration plant, not a commercial plant. So it's pre-commercial still. But
you're
we're learning.
But you're revenue positive, are you already?
We are generating revenue. We generated revenue pre-commercial last year. This year, we're going to generate, I believe, 10x revenue through this demonstration plant.
10x?
10x, yeah.
It's remarkable.
That's going to be next year.
And here in British Columbia?
Yeah,
well,
BC.
I can't tell you how impressed I am, because this is a challenge that I had seen some time ago and thought, the people who can figure this out are going to solve a very big problem in the world. And they're going to have a great economic opportunity to create jobs and contribute back to the environment that we live in.
Absolutely.
Congratulations. Thank you for coming in and sharing with us what you're doing at PH7.
Yeah, thank you so much. And it's an honor to be here. As I believe, residents of BC, I believe that's very important to establish this in BC, keep it in BC, and hopefully we can grow internationally soon.
Well, I wish you great success.
Yeah. Thank you.